Hello and welcome to this tutorial. In this discussion, we shall be looking at the ways of describing a set. Before we proceed, make sure you click on the subscribe button, like and share. Now, the ways of describing sets simply involve the various ways sets can be illustrated in a written form. We shall be looking at three ways of representing sets, and they include listing the elements, giving a word of description, using a set builder notation. In today's discussion, we shall be looking at listing the elements. Now, let's look at listing the elements. It is obvious and self-explanatory. Listing the elements simply involves encasing the element in curly brackets separated with commas. Now we also use the ellipsis points represented by three dots to indicate members that either extend to infinity or lie in between some listed elements. Now let's look at 1. For instance, we can say that A is equal to 1, 2, 3, 4, all enclosed in curly brackets with the elements separated with commas. 2. B is equal to 2, 4, 6, 8, dot, 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 dot. Now those dots you see there, those three dots you see there are simply known as the ellipsis points. The ellipsis points simply indicate that more elements follow and extend to infinity, especially when it occurs after the last named element are shown on your screen. Let's look at number 3. Z is equal to the ellipsis point, comma, -3, -2, -1, 0, 1, 2, 3, and so on and so forth, represented with another set of ellipsis points. As you already know, the symbol Z represents integers. So we can use the ellipsis point to begin the listing process and of course to end the listing process. This simply indicates that at both the negative and positive direction, we still have endless elements. Remember, integers extend from negative infinity to positive infinity. Now we can also look at natural numbers, and they include 1, 2, 3, 4, 5, 6, 7, comma, and so on and so forth, represented using the ellipsis points. As you can see, the elements are also enclosed in the curly brackets. Now the ellipsis points you see after the number 7 simply indicates that the list extends to infinity. Number 5, W is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. And as you already know, the symbol W is used to represent whole numbers. Once again, it is not possible to list all the whole numbers you can ever have, so we represent that using the ellipsis points. Let's look at number 6, which is a special example. For instance, J is equal to the set of prime numbers from 2 to 29. We have 2, 3, 5, 7, 11, 13, and we place ellipsis points, then 29. Remember, before placing the ellipsis point, you must always introduce a comma. Introduce the ellipsis point, and then of course another comma before the last element is also given. Now this is basically used to list the set of elements when especially it will be inconvenient to list all, especially for finite sets. It helps you eliminate a good chunk of the elements so that you can shorten your writing process. Remember, the ellipsis point in this case does not simply mean that the elements extend to infinity, since they occur between two numbers that are already known in the set. Obviously, if I wanted to avoid the use of the ellipsis points, I could have simply just display the element as shown on the screen. So you can simply say that J is simply equal to the set of elements, which is 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Thank you for your time. Don't forget to click on the subscribe button, like and share. I hope you really enjoyed this lesson. If you have any comment, please, the comment section is open. Leave it there. We are here to learn from each other. God bless you. It is my aim that we build an academic community on this platform. Thank you so much for patronizing us. We hope to hear from you. Goodbye.